Okay, we are on the last stage of analyzing the spot speed data, and right now we are doing a test. Okay, what test? The chi-square. Still you are saying chi, huh? Okay, huh? Say, no problem, no problem. I am noting down. Okay, and this is a check for what? Normality of the data. Okay, fine. Yeah, if the data is normal distribution or not, because the data is normal distribution, then you can apply the theorems of normal distribution. The Nazariya Abdul Wasat. Okay. Now we were making this table. Okay. What are the first two columns? Speed what? Upper limit and lower limit of speed groups, right? The third column? Meaning what? Number of vehicles in each group. Okay, how do I calculate this one? This is an equation. Okay. So what was X? The upper limit. Okay. After I get the Z value, what did I do to get this one? The table. Okay. Simple rule. Whenever you have the Z value, you have to go to the table. Okay. Then you got these values from the table. And then from them I got these. How? Which one is cumulative? This one or this one? This one is cumulative, right? So what did I do with this to get this? Subtract. Okay. So I took the difference of set of two values. Okay. Then the last step was the calculation of F. So you already have the probability of each group. How do I get F? What? What did I do with capital N? Yes. Probability multiplied by capital N or total of frequency. Clear? Clear? Okay. For the chi-square test, these coins are still here. Nobody wants money now. Do or die, right? It's not enough. Okay. For the chi-square test, I need two things, N and F. N and F. Do I have both? What we have discussed up till now? Do I have both of them? You don't have? We have. Believe me, we have. N we already had. And the last thing we calculated was F. I need these two things. Okay? So I can perform the test. But there is a check on the F values. There is a check on which values? The F values. Okay? And the check is that F should not be less than 5. Any F value should not be less than 5. If it is, we merge it with the next one. Okay? Any F value less than 5, we merge it with the next one. Now look at the table. Which value is less than 5? Start from the top.
2.
The first value itself is less than 5, right? So I'll merge it with the next one. So you merge the first and the second. Okay? The first is 1.8. The second is 2.6. If I merge them, will I get 5 or more? Will I get 5 or more? 1.8 and 2.6. Will I get 5 or more? No. We will not. Okay? So you merge two values, is still less than 5. So whenever it is less than 5, we merge again. Okay? So you tried the first two groups. It did not solve the problem. We will try the third one now. We will merge the 3. We merge now 3 groups. So obviously the third one itself is 5. Okay. So when you merge the first 3 groups, the answer will be more than 5. Clear? Okay. Look at the other values. Which other value is less than 5? The last two. Okay. And whenever it is less than 5, we merge. So if you merge 4 and 3, it will be more than 5. Okay. So no need to merge third group here. Clear?
Yeah.
Okay. So, and this column presents the merged value. Okay, the new F column presents the F values after merging. So you can see for the first three groups I have only one value, and for the last two groups I have only one value. Okay, so the second F column gives you the merged values. Okay, yes.
The last value is 4.74.
Sorry?
The last value is 4.74.
So what?
You can have the 3.8.
Huh?
The last value is 4.74.
There.
What if?
What if?
You merge it with the above. Yeah, you can merge it, yeah. Okay, you can merge forward or backward. No problem. But here, obviously, two groups are less than 5. You will merge them together first to see what happens. Okay, if the situation is like this, then you will try merging the small groups together. Then you will see whether I have to merge forward or backward. Okay, clear? Okay, so now in the new F column you can see all F values are more than 5. Okay, so that problem is solved. But the rule is whenever you merge F for any group, you have to merge its n value as well. Whenever you merge F, you have to merge n as well. So we merge the F of the first three groups. We have to merge the n of the first three groups as well. So you can see in this column, n column, 2 plus 3 plus 7. Okay, so it will be 12. Then you merge the last two groups. Okay, so you have to merge the last two n as well. Okay, 5 plus 5, 10. Clear? Okay. So then what is the condition? No F value should be less than 5. If it is less than 5, we merge. After you merge the F, you also have to merge n. But the rule is for F. The 5 rule, okay, is F for F. Clear? Okay. Now the chi-square is this one. Okay. So n minus f square upon f. Okay. So for each group you have n and you have f. So you can calculate the chi-square for each group. Okay. So for example, I have the first one which is 0.3644. So okay, so it is n minus f. My n is 12, my f is 10.08. You take the all the decimal places, no problem. Okay, divide by f. Okay, clear? So you do this for each group, and then in the end, what do you do? Total. 11.669 is what? Total. Clear? Any questions? Now what do I do with this total chi-square? I go to a chi-square table. Like we had the Z table, we have the chi-square table. You should have some coffee. Somebody reminded me this is the last day to have coffee. Okay, so this is the chi-square table. Okay, my final chi-square value 11 point something. I have to find it in this table. The values which you see are the chi-square values. These values in the table are the chi-square values. Okay. Now where should I look for my chi-square? First of all, I have to select a specific row. Okay, which row would I select? You can see the first column says DF. DF stands for degrees of freedom. DF stands for degrees of freedom. You can see it's written on the top. Okay, what is degrees of freedom? Number of groups minus 3. We have groups, right? In the speed data, we have groups. So you'll count the number of groups minus 3. Okay, how many groups I have? How many groups I have? 14. From where did you count? the combined values. Okay, you will count from here. This one, or this one. Okay, the number will be same. Okay, why not from here? Because we combined some of the groups. Okay, the actual number was not 14. The actual number was more. If there was no merging required, this one and that one will be same. Whether you count from there or there doesn't matter, right? But here we had to merge, so that one and this one is different. We will take from here. How many chi-squares we have? Okay, how many chi-square values we have? Clear? So this is 14. 14 minus 3? 11. Sure, right? You don't need the calculator. Okay. She is still doing it. Come on. Okay. 11. Okay, so I will come to a chi-square table. First column I will pick 11. Okay. Now you can see the values on in the top row. Okay. These values are cumulative probabilities. Like we had cumulative probabilities from the Z table. Okay. The top values in this table are cumulative probabilities for chi-square. Okay. So you can see all of them decimals obviously. My value, the value which I am looking for is 0.05. I am looking for a probability of how much? 0.05. Meaning what percent?
5%.
5%. That's why I keep on checking. Somebody said 50, huh? Okay. So I am looking for 5%. Okay. Now I selected the degrees of freedom 11 because I had 14 groups minus 3. Okay. Now what is my chi-square value? 11.6669. Sir. So I will come in this row, the 11 row, and I will see. Where am I? I am between these two. Okay. Yes. Okay. So I know the probability for this one on the top, and I know the probability for this one. You can see on the top. Okay. Clear? So what is my P now? I know the chi-square for 50%, I know the chi-square for 25%, and this is my chi-square. So what is the P for this one? Which value I am looking for? 5%. Is it more than 5% or less than?
Yes.
Huh?
No.
Less than, huh?
More.
Oh, 0.05. 0.05 means 5%. I know this is very difficult. You need like a higher order intelligence to convert the percentage to fractions. Huh?
Just multiply by 100.
This is difficult. If you say multiply by 1, it's easy. Multiply by 100, it has 2 zeros. What can you?
Zero is easy.
Okay. Huh?
Zero is easy.
Where zero is easy? Even that is not easy. Okay. So I am looking for a P of how much? 0.05. Okay. Is this more than that or less? More than that. More. Okay. Everybody now agree. It's more than that. Okay. If it is more than that, then the rule says that the data has normal distribution. Okay. If the P value for your chi-square is 5% or more, 0.05 or more, the data has normal distribution. The data is normal. So the central limit theorem applies. And whatever applies to normal distribution, you can do it. Clear? Okay. If it is less than 0.05 or 5%, no. Clear? Any question? Okay. Who did the interpolation for this one? You? Who gave you the value? You. Do we need interpolation? No? Why do you do it?
You said so.
I said so.
Okay.
Why don't we need interpolation?
Because it's between more than 5%.
The values between which you are interpolating, both of them are more than 0.05. So the answer cannot be less than 0.05.
Good.
So even without interpolation, there is no problem. You can tell me that P will be more than 0.05. Okay? Even without interpolation. So what's the rule? If it is more than 0.05, the data is now reduced. Got it? Clear? Okay? When a student said, no, I will still do the check. I will still do the interpolation just to check. Don't do it.
Then I will say,
I know your skills. You can still find a value less than 0.05. So don't surprise me. Okay? I can have a heart attack because of that. Okay, got it? Clear? Okay, there is a practice problem which has multiple parts and it covers everything which we have done in this topic. Chi-square, sample size, mean, median, mode, standard deviation, everything is covered. Okay, the answers are given and the graphs are given and so on and so forth. Okay, so try it yourself. You can match the answers. Even the previous example, we did not completely solve in the class. We just looked at the values. Most of the things were already done. The calculations were done. We were just looking at how it is done. Okay, so my advice is that you do the practice for that one and this one. Just take the data and do the calculations yourselves. Okay, just for the sake of practice. Clear? Look worried. What happened? Okay, whenever we talk about speed studies, we also talk about travel time studies because speed is related to time. Another name for travel time studies is journey time surveys, JTS. Okay, journey time survey or travel time study means the same thing. Okay, now what's the difference between a travel time study and a spot speed study? We are talking about spot speed up till now, right? If you are doing a spot speed study using a speed gun or a speed radar or an application, obviously you don't have time. There is no observation of time. But you can do spot speed study using time as well. You can have a distance and do distance upon time. You can do it if the things are not available. Okay, but there is a restriction then. Restriction on the distance. What's the restriction? 1000 feet, less than 1000 feet. So for a spot speed study, if you are taking time, it should be for a distance of less than 1000 feet. For travel time study, it's the other way around. Okay, so somebody did a spot speed study using distance upon time. And they are saying, no, take it as travel time study as well. No, we cannot. Okay, in travel time study, the distance is longer. Okay, the distance is longer. So you can see here they have mentioned it can be the entire segment of the highway, which will be in many kilometers, or it can be entire route, which is even longer. Okay, route means from start to end, everything. Okay, so for example, from your garage in the park in your house home to the parking in the university, this is the entire route. Okay, it can be from one city to another city, it can be from one country to another country. So travel time study can be as long as you want. Okay, clear? Can do it around the world as well. Okay, only takes 80 days, right? Nobody knows. Okay, that's good. Okay. Now travel time also has delay. Okay. So as part of travel time studies, you can also observe delay as well. Okay. Now where can we use travel time studies? You can use travel time studies for identifying problem location. So if I say this segment is a problem location, I mean what? This segment has more delay. Okay, if segment has more delay, this is a problem location, right? Okay. The opposite of that is level of service. Level of service, we will talk about it in other topics. Level of service means performance. Level of service means performance. Okay, so you can measure the performance of the highway using travel time studies. If the performance is good, what will be less? Travel time and delay will be less. Okay, so it can be used like this. We can use it for traffic assignment models, something which I mentioned in lecture 3 as well, or lecture 2. So this is number 3, right? This one is number 3, right? Yeah, I mentioned lecture 2. Okay, so whenever you decide which route to take from one place to another place, you decide on the basis of what? Travel time. Which one will be quicker, right? So this choice of route is known as traffic assignment. Okay, so traffic assignment model means what? It's an equation which tells you how many people will select this route and how many people will select that route and how many people will select that route. Okay, and because they are selecting on the basis of travel time, so we do travel time study to put it in the equation. Clear? Okay? Clear? Okay, then you can use travel time data for economic evaluation. Now, you have studied the course with the economics course, right? MENG something, right? Okay, so economic evaluation means what? It has two things, cost and time. They taught you that. So what am I doing here? Cost and what? Cost and profit, yes. Cost and profit. Okay. Sorry?
Fixed by time.
It will what?
It's fixed by time.
Yeah, it is affected by time. Okay. But in the end, you are making profit, right? So if it's a business or a project, then we know the profit. Okay, we sell it, we run it, okay, and so on. Put it for rent and you get the money. But what about highways? What about roads? What's the profit there? This is how the governments or the government departments measure the benefit of a highway. Somebody proposes a new project. Okay, let us build a bridge here. So they will say it will cost us this much, 500,000 BD for example, or 1 million BD or something. But what's the benefit out of it? The benefit is how much travel time it will save. Without the bridge, we have so much delay. Put the bridge, the delay will be less. So the saving in travel time is the benefit. For highway projects or infrastructure, highway projects, or any transportation related projects, the benefit is measured in terms of time. Okay, so you have the cost, the construction cost, the maintenance cost, the land cost, the equipment cost, and so on. But where is the benefit? The benefit is if this project is constructed, then how much time it will save. Okay, and time is what? Time is money, yes. Okay, then we can draw travel time contour maps as well. What is the contour map?
Lines for elevation.
Huh?
Lines for elevation.
Yeah, contour map shows lines for elevation. So our travel time contour map will show lines for time. Okay, travel time. Got it? Okay, I'll show you an example later on as well. How to do travel time studies? There are different methods to do travel time studies. The first one we will discuss is the test car method. Okay, what's a test car method? You want to take travel time observation for a segment. So you will hire a car with a driver, you will sit inside the car and the car will move from one point to another and you will be noting down the travel time from inside the car. That's a test car method. Okay, so you are employing a car with a driver and taking the observations from inside the car. Clear? Okay. Now since you are inside the car, you are observing the complete movement, so you know when the car stopped, right? And for how much time it will stop or it has stopped. So this stop time is what? Delay. So you can know the exact amount of delay as well. And you can know the reason as well. Why the car stopped. signal, traffic jam, accident. Okay. So what they do is they keep 2 stopwatches in the car. One for the total travel time. So when the car moves from the start point, they start the first watch, and they will stop it when the car reaches the end. This will give us total travel time. And then there's another stopwatch which is just used for the delay. So whenever the car stops, they will start the other watch. Clear? Okay. Now test car technique can be applied in 3 ways. There are 3 different ways to apply test car. All of the methods I am going to discuss is part of test car. Okay. We have floating car, maximum car, average car. What is floating car? Floating car, first of all, is applied to 2-lane highways. It's applied to 2-lane highways. What are we trying to find out? Average speed in a direction of a 2-lane highway. In floating car technique, we are trying to find out average speed of a direction on a 2-lane highway. Okay. So you let the test car move from one end of one point of the 2-lane highway to another point. Okay, and person is sitting inside the car and he is observing the travel time and so on. Clear? Okay, but there is a restriction on the driver. The restriction on the driver is he should maintain his position in the traffic flow, traffic stream. Okay, his position should not be disturbed from start to end. What do we mean? It's a 2-lane highway, right? So each direction, how many lanes? 1. Each direction has 1 lane. Each direction has 1 lane means what? You are in a line, right? You are in a line. So if you are the third in the line, then you should remain third in the line till the end. Clear? Okay? So that means you cannot do what? You cannot do the passing maneuver, right? You cannot do the passing maneuver. But what about others? Huh? They can or they cannot? They can, right? So what do we do about them? I have to maintain my position, right? I cannot go forward or backward. So I cannot be second, then I cannot be fourth as well. What? Fight with them. Very good. See?
Good solution.
Try it. Yes. He is the only brave person here. What else? I have to maintain my position in the traffic stream, so I will not pass someone else. But if someone else passes me, then what should I do? So what will happen? Then other people will also pass me, and then they will fight with me. Why are you going slower? The point is you have to maintain your position in the traffic stream. Okay, so if someone passes you, then you are allowed to pass. You are allowed to pass. Okay. To maintain your position, you are allowed to pass. To maintain your position. The restriction is to maintain your position. The restriction is not to, you are not allowed to pass. You are allowed to pass, but only if required. Okay. Why is that? Because passing is a 2-lane highway. So when you are passing, you went to the other lane, right?
Yes.
So you disturb the observation. So we don't want to disturb it. Ideally, we don't want to disturb it. But if somebody else disturbs it, then we have to compensate. Okay? Otherwise, you keep on letting everybody come in front of you. You are already getting slower. People are coming in front of you and getting slower. Okay? So to maintain the observation, I have to compensate. So to compensate, then I can pass. Okay? Clear? Then we have other one, which is maximum car technique. Maximum car technique is applied on multi-lane highways. Multi-lane highways. And what are we trying to find out? 85th percentile. Okay? In maximum car technique, I am trying to find out 85th percentile speed or 85th percentile time. Okay? Multi-lane highways. So again, we let the driver run from point 1 to point 2, start to end. And the restriction is he should go for as fast as possible. Have fun. Okay, as long as he or she is alive, just have fun. Okay, if he is still alive at the end, we will ask the travel time. Okay, clear? Okay, so if there is a truck, so now this is not, it's not a matter of choice that you should pass or not. If there's a truck which is slowing you down, you go to the other lane, try to pass it. Okay, if you are in the right hand side lane, the left hand side lane is going faster, you go there. Okay, so whatever means are possible to go faster, you take them. Okay, so in maximum car, this is the restriction. In average car again applied to multi-lane highways. Average car is also applied to multi-lane highways for finding out average speed. Okay, and in this case, no restrictions on the driver. There are no restrictions on the driver. Clear? So the first method of test car was floating car. Applied to which highway? Two-lane highway. To find out what? Average speed. Maximum car applied to multi-lane highway. To find out what? 85th percentile speed of time. Average car applied to what? Multi-lane highway. To find out what? Average speed, average short. Clear? Okay. There is one problem with this method. The problem is that you are putting extra cars on the road for testing. Your observation cars are not the regular drivers. The regular meaning people who usually are on this road. So if you allow too many cars to come at the same time, your test cars, I'm talking about your test cars. So if you employ too many cars, too many test cars on the road at the same time, you are slowing down the flow. You are affecting the flow. We don't want this. Okay, so there are limits given. So for normal highways, for normal roads, up to 10 test cars at a time are allowed. Up to 10 for normal roads. Okay, if we have a major highway and we are doing it in the peak hour, then you can go up to 50 as well. Okay, like the highway which we have in front of the university. What's the name of the highway? Sure. Sure. I can do +1 -1.
Sheikh Khalifa Highway.
Sheikh Khalifa Highway. Sure. We don't know, see. Okay, but you get the idea. A big highway with 3-4 lanes and 100 km/h, 120 km/h speed. On those highways, 50 up to 50 test cars is fine. Why? Because on those highways in the peak hour, the flow may go up to 5,000, 6,000 vehicles. So 5,000 vehicles and 50 test cars. No comparison. Okay, but for normal highways or for other timings, up to 10 is enough. So up to 10 is normal. Okay, more than 10 is a special case. For major highways and only in the peak hour. Clear? Okay. Another method of travel time study is the license plate method. In license plate method, we don't need any car, we don't need any drivers. It's very simple. You have two observers, okay, or set of two observers. One will stand at the start point, the other one will stand at the end point of your segment or your route. Okay. What will they note down? The license plate number of the cars which are passing them, cars, trucks, whatever. And also the time of their passing is noted down. So both observers are noting down which car passed them, they are noting their license plate number, and at what time it passed them. Clear? Okay? So in the end, once they are done with the study, they will come back and match their observation sheets. What will they match? The license plate numbers. Okay? So observer 1 recorded one license plate number at 2 p.m. Observer 2 recorded the same at 2:20. So now you know the travel time, right? 2 to 2:20. Okay, clear? Clear? Okay. Now the problem, there are two problems with this method. I told you it's very simple. It does not require a lot of people or things. But there are two problems with the method. In this method, you are only noting down the start time and the end time. Between them, we could have what? Delay. We don't know it. Okay, so from here to here, 20 minutes. Yes. But how much was the delay? Okay, the time of delay, the reason of delay, we don't know it. Okay. The second problem is the matching. Okay. One observer can miss some cars which the other one has noted down. It takes time to note down, right? It will take 2-3 seconds to note down any car or any license plate number. Okay. So in the meantime, when you are writing one number, the other cars are going. Okay. The other observer doesn't know which one you have taken down. Okay. So when you are trying to match, there could be, if there is no matching, then there is no travel time. Okay, I recorded this car at 2 p.m. The other guy missed it. So I don't know the end time now. Or the other guy recorded the end time, but I missed it. I don't know the start time, no travel time now. Okay, so you may do the study for 2 hours. I have 1,500 values, he has 2,000 values. In the end, we match. You wish. Okay, maybe in the end we will match 100, 200. Okay, clear? Okay, so these are the problems with this method. Okay, other types of studies can be, you can observe the entire segment from a vantage point. Okay, what's a vantage point? From the top, a high point from where you can see the entire segment. So you track the entire car visually. You are not inside the car, you are looking at it from the top. Okay, so like you were doing with test car, from inside the car, now you are doing it from the top. Okay, so this is one method of doing it. And then you can do the test car method with tracking devices. Instead of noting down everything yourself, put some time and speed tracking devices, distance tracking devices inside the car. When the car will move, these tracking devices will track the time and the distance and the speed and so on and so forth. Clear? Okay, so a test car can be applied with tracking devices. And the third one is, again, which can be done with any of these methods. Instead of manual visual observation, do observation through a camera. Okay. So for example, I mentioned observing from the vantage point, right? So don't observe it yourself. Put a camera on the vantage point. And then later on from the video you will do the observations. Okay. But then you need a high resolution camera because it has to be on top. You cannot miss it. Okay. For the license plate, again you can use the camera. Put two cameras, one at the start point, one at the end point. The camera will record the license plate numbers, and you can see the time from the video. The camera is recording it, is recording the time as well, right? Okay, clear? So the videotaping can be done with the other techniques. Okay. So we have the test car technique, we have the license plate technique. We have the observation from the vantage point. We have test car with tracking devices, and we have videotaping which can be done with any of them. Clear? Any questions? Okay.